think it's good to start. Let me first welcome you all to our this year's to the 2023 Distinguished Lecture in Energy organized by the Texas A&M Energy Institute. I'm Francis Christopoulos, I'm the director of the Texas A&M Energy Institute. And I just want to say a few words before introducing our distinguished speaker today. I mean, we live in an era where obviously everybody talks, and we have the conference competing with us as we speak in Dubai, talking about energy transition and getting scenarios for the future regarding the optimal energy mix, which will require a lot of investments, taming the carbon counting, the emissions and all this. And I think the Energy Institute at Texas A&M has an extremely strong record when it comes to energy and any space within. So we have an integrated program that looks holistically across the various aspects of energy sources and tries to not to take a position what are going to be the winners and the losers, but leave quantitative analysis, data, and models in any form to predict kind of and give advice of optimal kind of scenarios under conditions of significant uncertainty as we go ahead. And the nuclear question, which is the topic of our discussion, is one of those elements that should be looked in depth without any hesitation, and it's important for the state of Texas and the US and the world by large. And it gives me great pleasure to introduce our today's distinguished speaker, who is a worldwide known authority in the field, our very own Professor Yassin Hassan, who is the director of the Center for Advanced Modular and Micronuclear Reactors. We have and he is going to talk about this in a little while. He is a professor in the Department of Nuclear Engineering and Department of Mechanical Engineering here at Texas A&M, where he is a University Distinguished Professor, a Regents Professor, and he holds the Peterson Chair in Engineering. Before coming to Texas A&M, he had also a career. He worked for several years in the nuclear power division of Babcock and Wilcox Company in Virginia. And his research over the years has been focusing in the area of computational and experimental thermal hydraulics, with a lot of emphasis and focus on advanced nuclear reactors. He received his undergraduate degree from the University of Alexandria in Egypt before coming to the US, where he received his master's and doctorate in nuclear engineering from the University of Illinois in Urbana-Champaign, and the master's in mechanical engineering from the University of Virginia. He has been a very prolific author with over or close to 600 publications in technical journals and conference proceedings, and more than 400 authoritative summaries in the American Nuclear Society transactions, and have been a great mentor for a great number of PhD students, close to 65, over 100 master students, and over 20 postdoctoral and international scholars. For his work, he has been widely recognized across the globe with eminent awards, including the American Nuclear Society Seaborg Medal 2008, the Thermal Hydraulic Technical Achievement Award in 2004, the James N. Landis Medal of the American Society of Mechanical Engineering in 2017, the Fluid Engineering Award from the American Society of Mechanical Engineers in 2022, the George Westinghouse Gold Medal Award in 2003, and many more. He is a member of the Academy of Medicine, Engineering and Science of Texas. He's also a member of the Slovenian Academy of Engineering and he's a member of the U.S. National Academy of Engineering. So without any further ado, I would like to very warmly welcome Professor Yassin Hassan, who is going to elucidate whether nuclear energy should be indeed part of the energy mix of the future. Professor Hassan.
Introduction here. I don't know if that's me or that. Okay, that's great. It is a pleasure to have you here. I know you are busy since it is the last week and the final exam. I know the students are busy. Also, I like to thank the advisory board members of the Energy Institute. Thank you for attending the lecture. And what is really when I came to give this, I made some changes. And let me say, all these slides I prepared with my students, so I really didn't do anything. I just collected that work, which is the students' work along the many years related to the nuclear energy and the development. Even during that time, like we talked, nuclear was down, and now the last 3-4 years is becoming one of the areas which I believe we need it all. So the conclusion of the lecture, if you will, is we need all the energy sources. Hydrodynamic, solar, wind, nuclear, bio, to come up and relieve the pain we have, especially the last 2 summers. Especially last summer, we had the hottest summer since 1075, as NASA and NOAA recorded. The temperature went so high. It's not here on the US, in Texas, in New York, it's overseas, in the Middle East, in Greece, as you know, the temperature went very high, and also in Italy and in Africa. And the other part, so we need it all. Here is some of the work of my students. They work hard, so we put it to feature it. We can't have the time to cover it all, but it's really the work of my colleagues here, Dr. Yaz, Dr. Inan, Maria here. So it is a multidisciplinary work with different departments, engineering, and also social school. The first 3 is one of the advanced reactor. The reason also I put it, because it's supposed to be built in Texas, in Seadrift, in Dow Chemical, with a company X Energy for bottle beds. So that's one. The other one here is the wire red liquid metal, which is TerraPower, is funded by Bill Gates, his company, coming up with this type of technique to get rid of the waste, burning the fuel. And this is liquid metal sodium. Another one in Europe also is very active, was Westinghouse, is the liquid metal is called the lead. And Belgium is taking the lead on that by building this type of reactor by 2050. And the other one also, I believe it will be a good type of option of the source of energy is related to the heat pipe because of Westinghouse and NASA. If we go into the moon or Mars, we need power. So one source of the power might be nuclear, and this type of reactor, since it is a passive, it will be a good tool to get us there. Doing all of that, it needs science and technology. It is a multidisciplinary, as I mentioned, and it's interesting This tool helped our student is to use during the COVID for spray, sneezing. And so we will show some of the activity we did during 2 years or 3 during the COVID. We have one student is sneezing. That student zero, we did experiment to say the dispersion of this virus particle and so on. So as I mentioned, is most of the activity again is a student activity.
Humanity.
Okay, I'm sorry. Okay, this is a groups. As you see, it is a multidisciplinary, different department, mechanical, modular, agricultural engineering. Gavin is also, he's from Spain, a scholar. He's a visiting here professor, my researcher, and the students here. Plus, some of them already graduated, some recently. So that work really is a continuation of work we're doing. And we have a very strong collaboration with Texas A&M Energy Institute because to make the mix, to use it all, I think under the umbrella of the institute, the work need policy, it needs technology and the public policy is the master. So we're collaborating with Bush School and as I mentioned, with College of Agriculture and Life Science with all these investigators. Saying that, I believe one of the things
Humanity is in the oxygen. Today, Global Meteorological Organization and European Commission's Copernicus Climate Change Service are releasing official data that confirms that July 2023 is said to be the hottest month ever recorded in human history. And for scientists, it is unequivocal. Humans are to blame. All this is entirely consistent with predictions and repeated warnings. The only surprise is the speed of the change. The era of global warming has ended, the era of global boiling has arrived. The air is unbreathable, the heat is unbearable, and the level of fossil fuel profits and climate inaction is unacceptable.
So as you see, is really the increase of the temperature with that. And that it shows 1975, you can see it is flat, the number of the temperature. Then increase between 1960 to 2015, 2022 started. This is during 2023. It's amazing increase of the temperature. It's not even linear thing going exponential. This is the worst what we have. So in September, even ocean charted the globe record. And that what affected our economy and the recorded one, if the temperature going for 170 years in this record was the most warm days in September 2023. This accompanied also, as you can see, in different areas during the hot and high temperature. I show some of this overview what's happening. This increase when the temperature got very high, also in fire in Colombia and Canada, in Vermont, another in Greece, you can see all these people looking for water and finding. Some of the dogs looking at the swimming pool in China. The others here also in, I believe, in Arizona. And this one is in a zoo, is a tiger with the temperature reach 104. So you can come and try to relieve the hot weather. So without any doubt, there is a change, even as we see in the Middle East, using the tin to cool it, and fire and so on. So the conclusion is that 250 people is affected by this and having this, and there's a shortage of the water and energy. Also, that cost the $2 to $4 billion. And that the increase you can see from 18 to 22, as I mentioned, more carbon dioxide emission, the temperature. So there is a strong relation between the pollution or the emission of CO2 with the increase of the temperature from between 18 to 220. One other thing, so if we don't do anything, you can see by the end of this century, the temperature will increase 4 degrees. And according to the Paris Agreement, we're trying to do it 1.9 or 2 degrees to reduce the emission to come 2 degrees by 2030 and going flat after that. So what we're going to do here, going from here, as you see, this is shows the pollution since 1957. United States producing this million tons of carbon per year, but other country is increasing to produce more. And by 2020, you will see that China overrides United States and all the world, producing twice what U.S. production of the pollutions. This is what we have right now, as you see. So we have to work on reducing this type of pollution to keep order. Unfortunately, you will see also the other poor country who are not producing and need the energy are down here. So that's another, for the sake of what we're going to do to produce the safest and also the clean source of energy. This is the type of the energy sources which are causing our damage of the environment. And I believe one of the things we have to look down to have a mix of this type of energy sources to reduce the emission and get us in the level of the temperature we need. Solar, wind, hydropower, biomass, and nuclear. So that's the mix we like to have it to produce this. Using all the renewable energy of the mix, the solar, the wind, the hydro, and the geothermal. The solar and wind is intermittent. So you're working in a certain time under a certain, it's like, for example, the wind under a certain storm or so on. So there is one way is to do that. We can use all of this type of energy. You will find another source of energy, which is nuclear, is stable and work 24 hours, 7 days, all year round. And that's one of the advantages of nuclear to reduce that base power, then the changes needed can be implemented by solar, wind, and others. Saying that, the results.
Achieving sustainable economic development and averting the devastating consequences of unchecked climate change will require making use of all low-carbon energy sources. Studies confirm that the goal of global net zero carbon emissions can only be reached by 2050 with swift, sustained, and significant investment in nuclear energy. Since the beginning of the 21st century, nuclear power has avoided the release of some 30 gigatons of greenhouse gases. Today, it provides a quarter of the world's clean electricity and contributes to the achievement of the Sustainable Development Goals. Resilient and robust nuclear power has the potential to play a wider role in the quest towards net zero carbon emissions, while ensuring the highest level of nuclear safety and security. It can help to decarbonize district heating, desalination, industry processes, and hydrogen production. Nuclear power emits no greenhouse gases when it is produced and contributes to energy security and the stability of the power grid, while facilitating the broader uptake of solar and wind power. Locally, it cuts air pollution, which is one of today's biggest public health crises, causing the death of 8 million people a year. Net zero means nuclear power.
This is the Director General of IAEA, International Atomic Agency, but he also indicated who he names it. As Strasser mentioned, right now, this week, is going on the climate change conference supported by the United Nations, and it is holding in Dubai. And most of the president of every country is there. One of the things United States announced last week, declaration of triple nuclear energy. Senator Kerry, under the instruction of President Biden. So around the 20 countries signed that is to achieving global net zero greenhouse, and might be the way to go, or one is triple the nuclear energy needed for that. So that's one of the activity going through the conference is to reduce greenhouse emission and keep 1.1 degrees by 2030 and zero emission by 2050. So almost of the countries are signed to this agreement in Paris before, a few years ago, and under that conference, but they're continuing that work. But I like to mention, it's not only the leader of the legislature or the policy makers, it's also one of the things is the Pope Francis. He's supposed to attend the meeting, but he couldn't. But he sent his notes or his mission. And he did that twice. This one is during the month of June. He mentioned, according to the Paris Agreement, exploration and expansion of the fuel infrastructure. So he mentioned that during also some of the change of the risk. 2 days ago, he sent his indication that this problem is also a religious problem. So he mentioned, added that he said, I make this hard to fill the appeal. Let us choose life. Let us choose the future. And the cry of the earth, may we hear the plea of the poor, and we sensitive to the hopes of the young and the dream of the children. The destruction of the environment is offensive against God, and he indicated that we have to make a change to protect the environment. So that's one also a real comment too surprising from religion organization. First time they met in this type of conference, and I noticed also that they participated in the last meeting in September, the Peterson, in United Nations, talking about energy, and it was focused in Europe. It's not the only. Also, you can see our governor here in Texas, also in last August, he has, governor talks about nuclear at university fireside chat, and with Dow Chemical, as you know, they going with nuclear, Clay Snell, the president of X Energy, Modular Reactor, and Dow chair here, CEO, with the governor, with some of the other people. And what the government added mentioned, one thing we are looking at with a keen eye is the ability to expand our capability with generated power of nuclear power. So that was also interesting that we like Texas to be the main source of all type of energy: solar, wind, oil, fossil, and others. So that's one indication how that's important. As you know, Texas need power. Even we continue, we are the high of our production today, and we generate more power than California and New York combined, and we need more. So that's one thing, is the solar, wind, and the energy is good. So what is the situation in the United States right now? In US, we used to have in 1990, 104 nuclear power plants. Today, we have 93. I'm sorry. This is because it came 2022. In December 2022, there is Vogel added a nuclear power plant in Atlanta. So we have 93 nuclear power plants operating in the United States, producing about 19% of our electricity. 19% is a clean energy. Here is, you can see also all this country. In China, there are 58 nuclear power plants. This operating plant, and you will find that China is building another 20 nuclear power plants under construction right now. So they will see more or less in few years, the number of the United States. Also, one of the unique about this nuclear power plant is the performance reached 95%, 90% performance. It used to be about 70, 80% in 1980, 1990. And so we produce more power with this number, 92, more 147 or 4, which we had a few years ago. So the performance is there. So in other words, you can see 19% electricity produced by nuclear, 50% is clean generation of electricity, no emission of CO2. What they do is that 470 million carbon emission reduction, tons also prevented from NOx, SO2, 90% is the average capacity, as I mentioned. And that contributes $10 billion in GDP and $16 billion in contribution to the So without any doubt, that's one way also to go, plus the other sources. That's why U.S. utility, the last 2 years, for the objective of reduce the emission. And that target encourages them by looking how to build more nuclear reactor, and a lot like Pennsylvania is, and Virginia and other states already is considering that for their data center and also for replacing coal plants. How am I doing on time? Okay, thank you. Anyway, this one also, it's really close to my heart. In a sense, if you can see the country which they enjoy electricity in this area, they producing more pollution. And the poor country which doesn't electricity consumption zero, they produce less pollution. So it's environmental justice, and so they might have to do, and the United States noticed that. So last month, the administration established a training center in Ghana, and is that to educate these people about other sources besides burning coal is nuclear. So training center, as a matter of fact, the State Department approaching us is to help that center for education and for training. What is the solution? We need solar and without it, 50% of the energy by 2050, I believe, should be wind and solar, among others. Maybe 43% it can be nuclear. And that might be the lowest cost approach to reach this time with 1.9 degrees increase only, which our objective to follow. But if we change with certain boundary and constraint, 70% or 75% by wind and solar, 13% in nuclear. But even though we will need building new reactors, and to reach that objective, the cost will be close to $500 billion from the first. So it seems like nuclear can make it, so we need the business and main school to help us to reach that objective here and to reach electricity, for generation electricity, 43% of advanced nuclear reactor. So they're coming up with different type of reactor. They call this is a standard light water reactor 90 and so on. A small modular reactor you hear about. So what we're going from here in the US and the Department of Energy, we believe that an advanced reactor is safer, is small, and the micro reactor might be the approach to go, especially for underdeveloped country who doesn't have electric grid. And for our developed country, we need full-size nuclear power plant, small ones there. I presented this slide about 1 month ago. I used the word economically. The cost is less. But what happened is, misfortune that new scale found out they made their calculation that is costing really more than expected, so I dropped the economic here. There are different kinds of reactors, as I mentioned at the beginning. Liquid metal reactor, like TerraPower, Bill Gates, light water reactor is Westinghouse, Holtec, so high temperature gas, X energy, molten salt. We have a lot of new and several companies. Heat pipe is also Westinghouse. Since different kind of reactors, that's what we're trying to work on it as here in technology, to prove which one fits Texas and which type of reactor is important. Like if we need, for example, hydrogen production or desalination, maybe high temperature gas cooled reactor can help from this economic point of view with the mix. So there are explosion of this startup funding company. Every day, this is some of them here. You can see most X-Energy, but every day you can see a new companies come in. This moved to Austin just last month. It is kind of liquid metal reactors. Modular is another also starting from the group in South Carolina. So, but this is, there is a spectrum of this micro, very small. It depends how much power they are producing. But as you know, this reactor will have application, heat process, hydrogen production, electricity, among other things. Maybe also airplanes, concrete, and all this industry. If we know how to use them and connect it very closely, I think nuclear will be cheaper and might be safer in that regard. So see right now, they believe small reactor is inherently safe, so it's not the problem like Fukushima, Chernobyl, or 3 Mile Island, which nobody really got killed from this assembly. It can be built in a factory, faster construction, because construction of nuclear power plant, it takes many years and maybe improved. This is some of the opportunity demonstration nuclear hub, which is $7 billion in the bill, which is several billions funded and credits. And so there are a lot of opportunity here, and the administration encourages that. So you can see the opportunity for nuclear with other mix. It's around the world, especially in Africa, as to raise the standard for the health, economic, and the standard of life, which is important for that. One of the problems really between in nuclear, that the relation between the vendor and the supplier or the customer is a very long relation. It's a marriage. It's 30, 40 years. So it is for the security and the political reason. It's important for the United States, especially the competition overseas from China and Russia still is very extreme. And once they penetrate, that means it can go for 60, 70 years. Some of the reactors in Europe after Fukushima, they need uranium, they need some, and Russia did it all there. So that's why one of the things US, for the welfare of all the world, that US should get into that. I think this slide is okay. That also, because my student giving me some point, so I have to present it, otherwise I will be in trouble tomorrow. So here are some of the work we are doing. We developing the small microreactor. One of the things is a heat pipe reactor, and we doing different kinds of simulations and working hard to reduce this type of reactor. And we, Westinghouse is collaborating with us, and we, for this time of reactor, also my colleague here, Dr. Anand Maria, working with me, and ocean engineer. You can see this is the type, it's called the heat pipe reactor. So we have a lot of facility here. Some of the students are working on it. And one of the things we believe we should pursue through also Energy Institute is thermal energy storage system for solar to store it during the day, and the wind, even during the night, then when you need it in a certain time with nature. So there will be the interaction between all type of energy, the next through system to do that. And that's one of the things we hope to work on it, and I'm sure the state of Texas here. That will give you an overview of our facility here at Texas A&M, where is the last, I can say, 1 or 2 years of student are building this type of work, trying to get us to understand the phenomena and the technology of this advanced reactor, if it's liquid metal, heat pipe, and also water reactors. So that shows things. And you will come to visit our lab and to see the facility and interact with the students here. So this is what. Is that supposed to have sound there? Okay. So they have also electricity generation of this small reactor here, which is about a few kilowatt. So, and as I mentioned, this type of reactor, it's easy to work, especially in a space environment, like on the moon or in Mars. So that's not also, that might be interest for exploration of the space. Okay. See that's not. Okay. Okay, I'd like to show that because it's also one during our COVID. As students, we're talking about 6 feet, 10 feet. So we thought about how to determine with all our instrumentation here we have. With Maria, we worked in the spray and the droplet and the salt. So we did that through one of our, to get student to breathe, and this means it was very hot. But we had a spray, he graduated already. In Texas, he has always allergic. So he sneezed all the time. So he was a good instrument to do this. We tried to get other students, we failed. They sneezed one time, put paper and all of that. So he continued many hours and he was happy to do it. Sneezing, this is virus transmission, also is important, as I mentioned, the pollution, the hot weather produce a lot. So that's also connected in this kind of technology. So that's also encouraged us to have a clean environment and look into the water. So that students, when we work, we know this is important to the human, even to the church, as I said before. So that's another thing, and this is one of the paper published. The reason they put it here, because this paper is published during the COVID time. It got a lot of citation from NIH and other people, and they calling us. They thought we are in the medical arena. Of course, I don't know what kind. So, but it helped them to do. So that was really the idea from here. And one of the things, most of the experiments we did, the people they using a model in their literature, and most of the experiment, even Florida State University, repeated that they don't move the person, because when you sneeze, they do it like a model spray down. So we get the right action from zero, because he sneezes, shake his head, so we get the right boundary condition for this case. As you see, he's standing here, and we put the roller, we hit him with the razor, and get with the information here. So, this is the kind of what we did with the mobile with high stuff. So anyway, but we develop another curve because this is the curve which the people used before shaking the head. We did it, so we got a different stuff to do it with the hip, with the time, so develop equation and all of that is becoming like a multi-phase flow phenomena in fluid mechanics. So that's what we did here. And we compared it even here, the convention model without shaking. This was shaking the head. You can see the dispersion of the particle and the virus is here. Compared also with CFD result and so on. But also we tried to use the mask, but we did. This is supposed to be.
Thanks to the latest research into violent expiratory events or sneezes, we can now observe very closely the turbulent multi-phase cloud, which distributes a payload of droplets and mucous salivary ligaments, or, well, stringy gulps of spit at high speeds and over great distances. These gross but engrossing images are made possible by highly sensitive slow-motion cameras, which can track seamless spectroscopy. This is high-tech stuff, but the fascination with sneezing and the attempt to capture and examine the sneeze is actually as old as the moving image itself. This short film, known as Fred Alt's Sneeze, was recorded in 1894 to test a new moving picture machine called the kinetoscope. This 5-second long film, showing Fred Alt taking a pinch of snuff and then sneezing, captured the imagination of a public who were wowed by the idea that something as fast as a sneeze could now be captured, preserved and repeated. Of course, sneezes were also an object of fascination long before the cinema. For the ancient Greeks, sneezes could be an omen from the gods. According to one ancient Roman doctor, sneezing during sex could be used as a contraceptive. But the most common interpretation of
Okay.
Well, advanced small, modular, and micronuclear reactors at Texas A&M University, where the future of nuclear engineering is being achieved. This 14,000 square foot facility is more than just a lab. It's a dynamic environment where fundamental applied research transcends the conventional boundaries. Here, our dedicated students and engineers tackle complex thermohydraulic challenges across light water and advanced reactors. With the latest advancements in laser technology and high-resolution imaging, our researchers engage in precise measurement and analysis of fluid energy transfer. Our advanced visualization techniques, such as refractive index matching, particle image velocimetry, laser-induced fluorescence, and laser Doppler velocimetry, are at the forefront of visualizing and capturing every detail of fluid motion and thermal exchange. Our computational prowess is unmatched. Utilizing an extensive array of system-level and computational fluid dynamic codes. By utilizing the advanced modeling capabilities, we model and simulate the thermohydraulic phenomena that are critical to enhancing reactor safety and efficiency. Collaboration is the pulse of our laboratory. Seasoned experts mentor the next generation of nuclear engineers, fostering an environment of learning and discovery. It's a place where theoretical knowledge meets practical application, where every day is an opportunity to learn, innovate, and inspire. The Center for Advanced Small, Modular, and Micronuclear Reactors is more than a testament to research. It's a beacon of hope for a sustainable future, where the energy needs of tomorrow are met with the ingenuity of today. We don't just witness the the evolution of nuclear engineering. We tried it. Explore the depths of thermohydraulic research with us. Discover more about our work, our team, and our vision for a better world.
Okay, thank you. I have to show that my students, and I see they are here, so I'm glad we got time. Thank you, start the committee. Let me say, I see a lot of the students here. You are in that field. You are really helping to create a better future for all of them. And you are right now in a position to rise to meet these two things: stopping climate change and the most reasonable electric standard in all the world, in Africa, in Asia. That really will solve the problem. As a matter of fact, reduce the war. So supporting this kind, 800 people who live without electricity, without water, to create a cleaner life and more peaceful future. This is your mission here as a graduate, undergraduate student, and I commend you for doing that and looking forward for the future. Thank you.